we need to follow this equation because all the values are dependent on this equation. Because when we talk about uh, dependent and independent variables, we follow this equation. So this is y equals to a plus bx. So y is dependent variable and x is independent variable in this equation form. So when we are dealing with uh, regression analysis attempts to establish the nature of relationship between variables and provide a mechanism for prediction or forecast. Generally, why we do regression, we need to estimate or predict the unknown values of any variables. We do regression analysis. So, regression analysis is an absolute measure with the help of which we can estimate or predict the unknown values of variable from known values of another variable. So, variable whose value is estimated is called dependent regression values. I repeat, the variable whose value is estimated is called dependent or explained variable, whereas the variable on the basis of which the value of dependent variable is derived is called independent variable or repressor variable. Coming to classification of regression analysis, we have two types. One is change in proportion and number of variables. So change in proportions, we have again two types, linear regression and non-linear regression. Regression analysis model tells us when dependent variable moves in a fixed proportion of the unit movement of independent variable, it is called linear regression. So these linear regression when plotted on a graph paper forms a straight line. So mathematically, the relationship between x and y variables can be expressed by simple regression equation. I'll share with you. I'll show you how the linear regression. So this is the formula, that is y I equals to a plus bxi plus ei, where a and b are known as regression parameters and ei denotes residual terms. Xi represents value of independent variable and yi is the value of dependent variable. A expresses the intercept of the regression line of y on x, that is value of dependent variable y, when the value of independent variable, that is x, is 0. B denotes the slope of regression line of y on x. Again, ei denotes the combined effect of all other variables. So this equation is known as classical simple linear equation. So this is all about linear regression analysis model. And next we see what is non-linear regression analysis means. In non-linear regression, the value of dependent variable, say y, does not change by constant absolute amount for unit change in the value of dependent variable for x. So if the data plotted on a graph, it would form a curve rather than a straight line. In linear regression, what we have seen, when we draw a graph, we can find a proper straight line on it. But when we are doing this non-linear regression, if we plot on a graph, we find it's a curve rather than a straight line, and this we call it as curvy linear regression. It is curvy linear regression. So next one, we have seen the change in proportion model, where we have seen what is regression analysis model and what is non-regression analysis model. And coming to next one, that is number of variables. So number of variables, we have three types. Simple regression, partial regression, and multiple regression. So coming to simple regression, when only two variables are studied, to find the regression relationships, to find the regression relationship, it is known as simple regression analysis. It is known as simple regression analysis. One is treated as independent variable while the other as dependent one. So these functional relationship between price and demand may be noted as an examples of simple regression. I repeat, when only two variables are studied to find out the regression relationships, it is known as simple regression analysis. One is treated as independent variable while the other as dependent one. Functional relationship between price and demand may be an example for this type of regression. So next one is partial regression, when two or more variables are studied in a functional relationship, but the relationship of only two variables is analyzed at a time. So keeping other variables as constant. So such regression is known as partial regression. And coming to third one, that is multiple regression, when two or more variables are studied and their relationship are simultaneously worked out, it is a case of multiple regression. Study of growth in production of wheat in relation to fertilizers or hybrid seeds or irrigation and many more can be the examples of these multiple regression. And next one is regression lines. It's important. A regression line is a graphical technique to show the functional relationship between the two variables, that is x and y, that is dependent and independent variables. So it is a line which shows average relationship between two variables, that is x and y. So this is called estimating lines, and which gives us average estimation value of dependent variables and independent variables. So here dependent variable is y, independent variable is x. So generally, the regression lines shows the average relationship between two variables. So next one is regression equations, or we call it as estimating lines. So next one, that is regression equations or estimating lines. These regression lines are based on regression equations. So these are also known as estimating equations. So there are two regression equations, that is regression equation of x on y, and which shows the variations in the value of x and given changes in y. So the regression equation of y on x describes the changes in the value of y for given changes in x. So next one, we have methods of drawing regression equations, or we call it as regression lines. I'll show you. So these are the methods of drawing regression lines. There are two types. One is freehand curve, the other one is method of least square. So this freehand curve method, this method is also known as method of scattered diagram. So it is very simple method of constructing regression lines. And coming to next, method of least square. So the other method of drawing a regression line is a method of least square. According to least square method, the line should be drawn through the plotted points in such a way that sum of squares of deviations of actual y values from the computed y values is the minimum or least. Before going to problematic things, I like to share the formulas for you that will help you to do the problems. I'll You can note down. This is the first one. Least square. These are the continuation art of formulas. So these are the formulas we see in regression analysis. Once we know the formulas, then it would be easy for us to construct these regression lines. After these formulas, we'll see what is regression equations through uh, four types we have. One is from actual mean, assumed mean, observations, and observed data. So these formulas we have already discussed just now. One second. We can see the types. That is, there are four types in regression equation through regression coefficient. One is by taking actual mean, and second one is by assumed mean, and third one is by applying actual observations, and the last one is grouped data. And coming to problems, will do. So first one will do with the method of actual mean, how the problems are done. So first one, we see the problem, calculate regression equation So calculate regression equation y on x from the following data. We are given x values and y values. So x values are 40, 38, 35, 42. I'll share with you the problem so that you can see. So x values are 40, 38, 35, 42 and 30, whereas y values are 30, 35, 40, 36 and 29. So here is the problem with the solution part. So y values are, see x values 40, 38, 35, 42 and 30, whereas y values are 30, 35, 40, 36 and 29. So yesterday when we were doing some problems regarding correlation, we made some mean values to find out. So simple here, we need to find out what what is x total, what is y total. If we make the totals of x like 40 plus 38 plus 35 plus 42 plus 30, which gives us 185. So sigma x equals to 185. But whereas y 30 plus 35 plus 40 plus 29, which gives us 170 as sigma y. Now what we need to find out after this totals, we need to find out what is x bar and what is y bar. How will find out x bar? It's very simple. Sigma x by n. Here what is sigma x? Sigma x is termed as 185. What is n? N is number of items or number of values we got. So how many values we have? 1, 2, 3, 4, 5. We have total number of 5 terms, that is 40, 38, 35, 42 and 30. So we consider as n as 5. So 185 divided by 5, which gives us 37. So what we need to do with 37, I'll tell you. Once we completed the y bar. So same similar to y bar also we need to consider 170 by 5, which gives us 34. So here we see a column of small x and small y. How we got these values means, to get these values in a row, we consider x minus x bar. So what is first value in x? 40. And what is x bar we got? 37. 40 minus 37 will give you 3. So first value is 3. Second value, see, it's 38. X is 38. What is x bar? 38 minus 37. X bar is 37. So we get 1. And what is third one? 35 minus 37, which gives us minus 2. And what is next number? 42. 42 minus 37, which gives us 5. Last value, that is 30 minus 37, we get minus 7. Similarly, we need to do for y as well. So see what is y. first value in y, 30 minus 34, which gives us minus 4. Yeah, see. So first value in x is 30. 30 minus 34, we get minus 4. Second value 35. 35 minus 34, we get 1. Third value 40 minus 34, 6. 36 minus 34 plus 2. Then 29 minus 34, we get minus 5. So what we need to do next? We need to square these x values. Squaring of x. What is 3 square 9? Next one. 2 square 4. 5 square 25. 7 square 49. Next is y square. 14 square 4 square is 16. Then 1. 6 square 36. 2 square 4. 5 square 25. So what we need to do these squares, we need to make the total. So sigma x square, add up all the items in x square. 9 plus 1 plus 4 plus 25 plus 49, which gives us total as 88. So next one, similar to this, make the total of y. 16 plus 1 plus 36 plus 4 plus 25, which gives us sigma y square equals to 82. So after this, what we need to do, what they ask us to find out, they ask us to calculate the regression equation y on x. So here we need to find out only one equation, that is y on x. So here we have a formula, byx equals to sigma xy by sigma x square. So here what is the total? How, before going to that, we need to see how we got this xy. X into y. What is x value? 3. And what is y value? Minus 4. 3 into minus 4, we get minus 12. Similarly, next one. 1 into 1 is 1. Next value. Minus 2 into 6, minus 12. Next, 5 into 2, 10. Next, minus 7 into minus 5. We get 35. Now make the total. Plus values plus, minus values minus. So we get 21. 21 as sigma xy. So what is the equation here? In first itself, when I have started, I have said you the straight line equation, that is y equals to a plus bx. So here they ask us to find out regression equation y on x. So here regression equation y on x. So what is y? Y equals to a plus bx. So here what is y again? Y is y minus y bar equals to byx into x minus x bar. So here we don't know what is y, and we know what is x bar. X bar is 34, and we know what is byx. Byx value is 0.24. 0.24. We don't know what is x. What is x bar? X bar is 37. So next line, y minus 34, which equals to 0.24x minus 8.83. So how we got 8.83 means 0.24 into 37. So 0.24 into 37 we get 8.83. So we need to simplify this equation again, like what will be y? Y equals to 24 or to 0.24x plus 8.83. So we'll see what next, how we can simplify the y. So continuation of this problem I will share with you at the last. Before that we see. So y minus 34 equals to 0.24x minus 8.83. So y equals to 0.24x plus 8.83. So next equation, y equals to 8.83 plus 0.24x. I'll share, you'll understand. Yeah, like this we need to put in a equation form. So y equals to 8.83 plus 0.24x is our answer. Why we got this answer means, if we see in starting the problem, see, so the answer should be in this form: y equals to a plus bx. So a value is 8.83, b value we got as bxy, byx 0.24, and what is x? So this is a regression equation y on x. We'll see one more problem where we'll have two equations, that is x on y and y on x. Note a question. Second problem. This is the question given to you. Given the bivariate data x and y, x is 15321273, y 610012212115. So what we need to find out? We need to find out regression equation by taking deviations of items from the mean of x and y respectively. So here we need to find out both regression equations, that is y on x and the other one is x on y. So first what we need to do, we need to do totals of x and y, and we need to find out what is sigma x by n and sigma y by n, so that we get x bar and y bar. Just give a glance. We have seen the previous problem and this problem. After seeing this table, first we need to find out what is sigma x by n. What is sigma x here? 24. And what is n? How many variables are there? N is 8. So here 28 by 24 by 8, we get 3. So what is y bar? Sigma y is 16 by 8. We get 2. This is step 1 and this is step 2. So what we need to find out next? We need to find out what is sigma x, x, small x, that is x minus x bar. So here we know what is x, 1 minus 3 we got, right? X, so 1 minus 3 minus 2, then 5 minus 3, 2, 3 minus 3, 0, 2 minus 3 minus 1, 1 minus 3 minus 2, 2 minus 3 minus 1, 7 minus 3, 4, 3 minus 3, 0. Similarly, we need to do for y also, like y minus y bar. So that gives you y. What is y here? 2. 2 minus 4. Y is how much? 6. 6 minus 2. We get 4. Then 1 minus 2 minus 1. 0 minus minus 2 minus 2. Then 1 minus 2 is minus 2. 2 minus 2, 0. Then 1 minus 2 is 1. 5 minus 2 is 3. So we got what is x, what is y. Now what we need to do next step, x square, squaring the x values, small x values, and squaring the y, small y values, so that we get x square and y square. So you see x square, 2 square 4, 2 square 4, 0, 0, 1, 2 square 4, 1, 4 square 16, 0. Now make the total. What is sigma x square equals to 30. Similarly, y square you need to do. 4 square 16, 1, 2 square 4, 2 square 4, 1, 1, 3 square 9. Now make the total of sigma y square. Sigma y square, which is equals to 36. Now what you need to do? We need to find out what is x into y. X means small x into small y. So minus 2 into 4, minus 8. 2 into minus 1, 2. 0. 0 into minus 2, 0. Minus 1 into minus 2, plus 2. Next 2 into minus 2 into minus 1, plus 2. 1 into 0, 0. 4 into minus 1, minus 4. Next last 0 into 3 is 0. Now similarly make all the totals, plus values plus, minus values minus. So we get minus 10 as sigma xy. We got what is sigma x square, y, sigma y square, and sigma xy. So now what we need to do, we need to find out what is regression equation y on x. So that is, so here what is y? Y is nothing but bx. So in previous problem we have seen how to find out b. It is very simple. We need to substitute b equals to sigma xy by sigma x square. So here what is sigma xy? Minus 10. Minus 10 divided by 30. So it is somehow point 33 something. Minus 10 divided by 30, we get 0 minus 0.33. Yeah. So next what we need to do, we need to substitute in the equation we get. So see here, y is equals to minus 10 by 30x. So which is equals to minus 0.33x. So next what we need to do, we need to see what is y and what is x. So if we see here, x is 3, x bar is 3, y bar is 2. So we are putting here. So y equals to y minus y bar. What is y bar? 2. And x equals to x minus x bar. So x bar is 3. So y minus 2 equals to 0.33 x minus 3. So y minus 2 equals to minus 0.33 x plus 0.99. How we got this 0.99 means minus 0.33 into 3. So next equation, y equals to minus 0.33x plus 2 into 2 plus 0.99. So we get 2.99. So next equation, y equals to 2.99 minus 0.33x. So you can see this is first equation, that is y on x. So simply give a glance so that we can do the next equation, that is x on y. So this is next part, that is x on y. So we need to find out here what is x equals to by. So here what is by means sigma xy by sigma y square. So we know what is sigma xy, that is minus 10, and what is sigma y square, 36. So in next step, if we see, we need to substitute these values. If we simplify this minus 10 by 36, we get 0 minus 0.28. So x equals to minus 0.28 y. So if we see x equals to x minus x bar value is 3. And what is y? Y equals to y minus y bar. So y bar value is 2. So next, simplify this formula. X minus 3 equals to 0 minus 0.28 y minus 2. So x minus 3 equals to 0 minus 0.28 y plus minus 0.28 into 2. You get 0.56. So in next line, x equals to 3 plus 0.56 minus 0.28 y. So this is another equation we got, that is x on y. So give a glance how we got this. See the steps. So these are problems easy when we apply formulas. Then it will be easily understood. If the problems comes in exams like x on y or y on x, so these kind of a problems comes in your exam. So these problems are simple and easy to understand. So in next class, we would like to see the problems in second method. We have seen there are some four types of methods. I'll check it. I'm checking. I have shown you there are four types. So that first method as we have completed, that is actual mean method. Uh, so in next class, we'll see with assumed mean problems. Okay, in next class, we'll see the problem based on assumed mean. As I said you, there are four types. That is taking deviation from actual mean, taking deviation from assumed mean, applying observation methods, and applying group data. In these four types, we have completed the first one, taking deviations from actual mean. So in next class, I'll start with taking deviation from assumed mean. So we are doing this problem based on regression equations through regression coefficient. So next class we'll deal the problems based on regression, taking observations through assumed mean. Assumed mean is over. Actual mean is over. Now we need to do with assumed mean in next class. So assumed mean method means like we need to assume a value, then we need to apply it. We'll see you in next class. Thank you, everyone.